Hi, everyone. My name is Placona. I'm a developer evangelist for a company called Twilio. Just out of curiosity here, who's never heard about Twilio before? OK, some people. Good. So Twilio is a developer API. So it's a communications platform that helps developers adding messaging, voice, and video into their applications. These are the applications you're already building using the languages you already know. But I'm not here to tell you about Twilio today. I'd be more than happy to talk about Twilio later on if you want to. But I'm not here to talk about Twilio today. I just want to tell you a little bit about me as well. So I just said I'm a developer evangelist there. There's some information about me here. So my Twitter account, my GitHub. So all of the code that you're going to see here today, you can find on my GitHub account. And there's also AndroidSecurity.info, which is a security website I run that is all to do with Android security. So most of the things I'm going to tell you here today, if you want to go into more depth, you can see some articles in this website. But this is enough about me, OK? So let's just get started with this. And I want to get started by just letting you all know one thing. I'm not a hacker. OK? So some of the hacks you will see here today, maybe you would be able to do better yourself. Maybe you're a much better hacker than I am, if that's the thing that moves you. So I'm not a hacker. I'm not here to try and teach people how to hack. I'm here to teach people how to not be hacked. OK? All of the things you're going to see here are things that come out of my own experience, just trying to find flaws, trying to find bugs in applications, and all of the things you will see here as well are things that I found and I reported to the developers. I wasn't trying to do anything wrong here, OK? But I just said I'm not a hacker, but there's this one thing I really care about, which is security. And just in case you're wondering, this is just a cool picture with a bunch of cameras. This is not the front of my house. But I do care about security quite a lot. I just told you, I look for bugs, I look for flaws, I look for vulnerabilities in applications. I hack some of my friends' applications and tell them, hey, you need to look at that. And I try and help developers fixing those problems so they don't suffer from the same hacks that I'm going to tell you today. But there's a small disclaimer I need to give you here. And this should be really easy for you to just read real quick. But the most important thing here is not all this garbage here. The most important thing here is I haven't really hacked your app, OK? I haven't really hacked your own app. I hacked a few apps. I hacked some of my apps. And the examples I'll give today are hacks that I've done on my own apps. Some of those hacks and some of those apps will have similarities with apps that maybe you know of. But I can't be naming names here today. And the reason I can't really be naming names is because usually when you do that, companies tend to get suey. And this is a total made-up thing, OK? Suey, in my opinion, is to become annoyed when someone or with someone breaks your toy, OK? So if I came over here today and I said, I hacked such and such applications, the owner of these applications could be here, and then I could potentially get in trouble and get sued. So this is my quick disclaimer here. I'm not going to be naming anyone's. This is not my intent. Like I don't want to shame anyone, but I will be talking about some exploits I found. But let's get started. I think all of you will have seen a diagram that looks like this. Okay, so this is your basic client-server communication. So you have a client in one side, you have a server on the other side, and what happens here is the client makes a request. So let's say this is an HTTP request. The server then responds with a response. OK, very simple. Most people have seen an HTTP request here, and cool. However, the hack I just showed you now is a different version of this, because what I've done is I've added an extra character here, which I'm representing with the pirate flag. OK, so you saw the mask. And the way this hack works, this hack is called man in the middle, and the way this hack works is you introduce a new character into that communication, and basically when a client makes a request, that request, instead of going straight to the server, goes to this new character here. This new character then makes a request to the server, and the server responds. So neither the client nor the server know what's going on here. So the client thinks they're making a request to a server, the server thinks they're just giving a response to a client, but there's someone in the middle. And this person in the middle is who's intercepting every single one of those requests. I'm talking about passwords here. I'm talking about tokens. I'm talking about like the real important things that you may have in your app that you now think you're passing straight to the server, but there's someone else in the middle. Why is this hack important? And what is a good example of this hack?
I wanna be the very best.
Who's still playing Pokemon Go here? There's always this one person. So Pokemon Go is the classic example of the man-in-the-middle hack, okay? If you're not playing Pokemon Go, or if you never played Pokemon Go, I'll just very quickly just take you through the premise of Pokemon Go. The premise is, you have an app, you walk around, and you catch Pikachus. That's it. This is what you do in this game, okay? However, I just said the key thing here. You walk around. So this is a map, and this is like a Google Maps where you walk around, and the more you walk, the more Pokemons you find, okay? Developers sometimes tend to not want to do the whole walking thing. And what the developers did in this case, so these weren't hackers, okay? These were kids trying to catch more Pokemons. They used the man-in-the-middle hack. So instead of having to walk around, they built this thing here. So now, all you have is a bunch of arrows that takes you wherever you want to go. So regardless of where you are, you can be sitting at your desk, you can be sitting at your couch, regardless of where you are, you can now move around and you can catch more Pokemons. Okay? So I just wanna stop here for a bit to say that the motivation on this one is basically to catch more Pokemons. So if you're not into Pokemons, you would probably not be using this hack. Okay? People who wanted to do it, they just found out how to make requests to the API directly so they could move around. But let's stay with motivation here, because the next hack I'm going to tell you about is one that personally for me gives me way more motivation. Let me tell you a story about Gretzky. Has anyone heard of Gretzky here? Cool. So Gretzky is a Polish developer who hacked an Android application to get rewards. So I just told you about motivation. The motivation here is obviously beer. That's a much bigger motivation in my opinion. So no Pokemons, beer, okay? This is an article about Gretzky, and I just always like to point something out in this picture here, because this is obviously not Gretzky, but if you look at the bottom of this image, it says, a strangely dressed man drinks beer. I know a bunch of Polish people, and I don't think they dress like this when they're hacking or drinking beer. But anyway, the way he managed to hack this application is he hacked it by loyalty. And I'll explain why he hacks this application via loyalty. So imagine you have your common loyalty application where every single time, so I've seen this at Starbucks, where every single time you buy a coffee, you get a star. If you buy 15 coffees, you get a free one. So you just get points for it. A bunch of places do loyalty, and as it turns out, in Poland, there was a loyalty scheme where every 5 beers you bought, you would get a free beer. Okay? So let's stick with the motivation here. 5 beers, 1 free beer. Great motivation in my opinion. The way he managed to hack this application was he noticed that every single time he walked into the bar and he ordered a beer, the person behind the bar would ask him, hey, can I just scan your phone real quick? And you would say, yeah, of course. When they scanned your phone, the phone would communicate with a beacon. The beacon would then return some information that this phone will pass to a server, just like this. Okay? This information would have been stuff like tokens, what product you wanted, so if it was beer or if it was burger. So this was the way this app worked. Now, Gretzky thought, okay, if it's my phone who's making a request to the server, surely I should be able to make requests to this server as well. Sure enough, he put an HTTP proxy in the middle, so he now had a man-in-the-middle hack where every single request that came from his phone would go to the server. And he was able to intercept that request to the server. And he ended up with something that looks like this. It doesn't matter if you're at the back and you can't see, but this is just a bunch of it's just an HTTP request. There are some important things in here, which is, one of them is called, this is the real HTTP request, okay? I didn't change anything on this. One of them is the authentication token. The other one is information about this beacon, like major version, minor version. If you have used the beacon before, beacons are like this simple. And the other one was the product. So was he buying beer? Was he buying burgers? So it's information about what products you would be getting for free whenever you got 5 of them. Well, sure enough, with access to this, Gretzky should be able to make an HTTP request to that server. So instead of going to the bar and buying beer, he could just go and make multiple HTTP requests to that server. And sure enough, he did. Every single request, 1 free beer. Every single request, 1 free beer. Every 5 requests, 1 free beer. So it's not very difficult to just make 5 requests and get a free beer, right? So that's the motivation again. And to this day, it's unknown how much beer Gretzky got access to. This is not Gretzky, by the way. But it's unknown how much beer Gretzky got access to. All I know about Gretzky was he wrote about this in his blog. So he has a blog called BreakDev, and he wrote about this. And Gretzky used to write on this blog maybe once a month, like in a sort of like regular cadence. And it took him 10 months to write again, ever since he posted this. So I don't know if Gretzky got access to so much beer that now he was busy with other things, or if he actually got in trouble because of this. Again, his intention wasn't to shame anyone, so he didn't even say what the name of the application was. I'm sure that if you're in Poland, you had used this application before and you would know it, but he wasn't trying to harm the company. Like, he wasn't trying to harm the people behind the application. He was obviously getting free beer, but he wasn't really trying to harm anyone, so he didn't publish information about this. But then, it begs the question, what could these developers have done to stop such a hack? Okay, because, it was a fairly simple hack. He didn't have to do much. So what could these developers have done to stop it? There's the first thing here, which I think they could have done, is they could have encrypted all the values. Okay? Like, we've just seen what the request was like, and there was an authentication token in plain text on that request. So encrypting all the values would have helped, okay? Because now it wouldn't be in plain text, and it's harder for you to make a request when it's encrypted, because like the other side needs to know what the key for this encryption is to read these values. So encrypt all the values, don't pass data in plain text, because it's just too easy to read. It's just too easy to replicate. Now, if you're an Android developer, I will be giving Android examples here. Most of the things I'm talking about will serve you if you're also an iOS developer, for example. But if you're an Android developer, if you wanted to encrypt values, you could use something like this. Okay, so this is a library, and it does AES encrypt, so it encrypts a value. And the basic idea of this is you add this dependency to your application, then you have a message that you want to encrypt, and you just call encrypt. When you want to go ahead and decrypt this message, you just go to the other side. Okay, so you go encrypt and decrypt. But I want to point something out here, because when I gave this talk for the first time, people were like, well, yeah, but there's a problem with this. There's a password in this code. And obviously, if there's a password, then this is not really safe, is it? Because there's a password in it. Like the password is inside your code. And what happens when you have a password inside your code? Usually ends up in GitHub. I'm sure some of you have done this before. You have a password, you forget about it, and it ends up in GitHub. So this is a good example of why you should be careful with having passwords inside your application, because they will end up in GitHub. This is a real story about a guy called Luke Shadwick who posted, well, he made he pushed some code into GitHub, into a public repository with his AWS key, his Amazon AWS key. And he realized he had made a mistake 20 minutes later. So it took him 20 minutes to say, oh, I actually made a mistake. But if you look at the bottom here, in 20 minutes, he had a $3,500 bill. In only 20 minutes, okay? Because there are people on GitHub who use the API to try and find this kind of information. So they're using things like regular expressions, for example, to look at tokens. They're looking for things like AWS key, password, token. They're looking for those things, okay? And obviously when they find, what do you do when you find a token for AWS? Of course, you mine Bitcoins. And that's exactly what happened. So some people got access to his AWS key. They started to spawn a bunch of virtual machines on AWS, and they started mining Bitcoins. If you have tried to mine Bitcoins in the past, you will know that mining Bitcoins doesn't really make you any money. You spend more money in electricity than you spend than you get from the Bitcoins that you mine. However, if you're mining them for free, that's free money, regardless of how much you make. And obviously, we're talking about almost $3,500 here. So imagine how many VMs these people spawned within those 20 minutes. Probably a lot of them. The good news here, if you're wondering, the good news here is there's an update on this blog post where Luke mentioned that he got in touch with Amazon and he was like, I don't know what's going on, but I have all this bill here. And Amazon was like, well, yeah, that's because you've got a bunch of VMs. And he was like, no, I don't. So he tried to rotate his key. By rotating his key, he found a bug on Amazon. And this bug was, when you rotated the key, it was still cached. So people could still use it even after he rotated. So he almost got a bounty here. And Amazon says, no, it's OK, you don't need to pay us. Like, you found a bug. It's something that is actually causing you harm. And we know it's not you, because a bunch of people do that. So it's OK. So if you were looking for a happy ending here, it actually happens. Like, this is you know, in a bad situation, it's actually OK, because he didn't have to pay anything. His account was used, but he didn't have to pay anything. But anyway, let's talk about more things that developers can do to stop those kind of hacks. Utilizing security features when they're available, OK? So I showed you that there was an IBeacon in the process, and the IBeacon was passing information to the device. The IBeacon wasn't passing information to the device in any kind of secure way. But as it turns out, if you are using IBeacons, there are things you can do. In this case, you can secure your IBeacons. You can make sure that your IBeacons are encrypted. So when they're passing information, they're not passing information in plain text. So all I'm trying to say here is make sure that if you are using external things, you know of all of these security features this thing has. And I'm not trying to tell anyone to use IBeacons here, because it's definitely something I wouldn't use. But if that's something that you're into, then make sure that you look for security features on this thing. Certificate pinning. How many people have heard of certificate pinning here? Oh, that's very good. Certificate pinning is the process of making sure that your application uses a secure HTTP, a secure SSL certificate, and it communicates to the server using that certificate. And basically, your application will only make a request to the server if the certificate is correct. And on your server, you can check for that as well, which now means anyone who tries to spoof your certificate won't be able to do that, because now you're pinning your application to the server. You're almost like bounding the two of them together. Doing certificate pinning, if you're an Android developer, you probably use OKHTTP. And if you do, this is what certificate pinning in OKHTTP looks like. You have a host name, which is basically where your server is. You create a new certificate pinning with your public key. and then you create a new certificate pinner. And that went too fast for some reason. So this is all it takes to use certificate pinning. One thing I should point out as well, if you look at the bottom here, I have some URLs. Those URLs basically take you to articles about this topic. I will be publishing the slides later, so it's OK if you don't want to copy the URLs or take pictures. But by all means, there's some information at the bottom here. Now, the other thing they could have done, and the other thing all of us should do is, like, do not trust a device. Because a device is not a server. A device is yours to do whatever you want to do with it. And sure enough, it's very easy to just do anything you want to do with a device, with an application running at a device, if you have access to it. And I'm saying this because eventually someone will decompile your application, okay? The first time I read about decompiling Android applications, I was like, this sounds so hard. This is so complicated. Like, I'm not sure I'd be able to do that. There's an application, well, there's this apps tool, which basically helps you decompiling an application. It's called APK tool. And with APK tool, you run it on the command line, and you pass an APK, and it decompiles it. That's all it does. So if you think, well, yeah, does it take a while to decompile an application? Look at that. I have an APK here, and I'm using APK tool, Realm Notes. So Realm Notes is the name of the APK I'm using here. And there you go. I decompiled this application. Once I decompile, I now have access to everything that is inside of it. So what I'm doing here is I'm looking for keywords inside this application. So I'm looking for oath, passwords, username, and sure enough, I find it. Again, this is my application, so this is one application of mine that I hacked, but because I had information inside the resources file, whenever someone decompiles it, they just get access to everything. But then I'm telling you, okay, you shouldn't have any kind of passwords or usernames inside your application. And then you ask me, but, well, I actually need those magic strings. Like, if I'm going to use an API, what do I do? Like, where do I go? Like, where do I get my keys from if you're telling me you shouldn't have them on the application? So there's a few options for you. The first one is, if you have them, encrypt them. If you must, if you really have them in your application and it's really hard for you to move away from it, encrypt. Just make sure everything that is in your application is encrypted and not easily readable. The other option is get your keys from a server. If you're using something like certificate pinning, for example, it's very easy for you to say, hey, instead of getting my keys from the application itself, I'm going to make a request to my server, the server I own, and I will get those keys from there. So that's another way you can do it. There's a third way, which is one way I've been recommending to some people, which is use the Decay. So the native development kit in Android means you can build. So there was an Decay talk earlier today. But what you can do with the Decay is you can build a module, and this module is going to get compiled. So it's a C++ module. It's going to get compiled, and that's going to go inside your application. You can have your keys inside this module. So what happens when you decompile an application that has a module like this? Nothing. You get access to the module. Like, you're going to have a .so file, which is still compiled. Now, if you ever tried decompiling a C++ module, you will know that it's way harder than just using an APK tool. It's way, way harder. And I'm not saying that it's impossible to decompile a C++ module, but for the Pokemon hacker, for example, it's probably not as accessible. It's probably not as easy. So what you're doing here is you're adding an extra layer to your application. So it's an extra layer of security. People will still be able to get that data if they really want to, and if they really like, they really want what's in there, but it's way harder. So this will stop some people. Again, there's URLs at the bottom, and slides will be published. But the thing is, I'm telling you about things that developers can do to stop the hacking. But obviously, when you're trying to stop that, you're already in trouble because you've been hacked already. So that's not a good place to be, okay? Like, if you've been hacked already, you're going to try and do some damage control. But you've already been hacked. So what kind of things can you do to proactively protect your applications. What are the sort of things you can do? The first one is adding tampering detection. An Android application, there's a way for you in an Android application to know whether this application has been decompiled and modified, okay? So I'm showing you one example here of what this looks like. So I have a couple of vendors here. So I have the name of my package, I have the Play Store, and I have the Amazon Store. And what I'm doing in my code is I'm checking first if the application has been renamed. So if anyone downloads my application, renames it, and republishes, this happens a lot, but we'll get to it. If anyone does that, I can tell the user, hey, you shouldn't continue. There's something wrong here. Do not continue. I'm also checking that the application has been relocated. So if anyone downloads my application and puts it in an alternate market, I can also tell the user. And what you're doing here, you are really serving your users. Check for application signature is the same process. Every single time you package an application, it generates a signature. This signature comes from your keys. So if anyone else who's not using your keys packages this application, the signatures won't match. And that means now, if the signatures don't match, your application can say something like, hey, get out. This is not my application. This is not the droids you're looking for. And then it's only a matter of time, really, because so this is a Google search I did not too long ago where I searched for my app was copied, Android. And I was trying to see how many people actually have this problem. And I had quite a few results. There's 4.5 million results for people who go to forums, people who go to the internet and say, hey, my application was copied. Someone's doing that to me. So don't think that this is not going to happen to you, because it will. Check for rooted device. There's a caveat here. Checking for rooted device means if you're not going to allow people to use your application on a rooted device, then people with a rooted device won't be able to use it, which sounds obvious. However, a bunch of people use rooted device for good reasons. So if your application takes payments, for example, you might want to check for rooted device. If you have a game, maybe it's OK for people to use your application on a rooted device. This is just one example of how you can check that. You just try and execute a command, and if you try and execute something like su, for example, super user in Android, if you get true, it means this device is rooted. Then you can make a decision. Things like Xposed, for example. If you've not heard about Xposed, Xposed is a framework that in itself, it doesn't do much, but it's got a bunch of plugins that people use to exploit applications. One of the exploits in Xposed is called hooking. And the idea with hooking is you now have a package, and inside this package, you're going to check for every single time this package is called, you can get information about it. This example doesn't do any harm. This example is looking for the clock. So every single time the clock changes, I want to add something to the bottom of it. That's it. It doesn't do any harm. But with this, there's a lot of things you can do, because you now have access to every single thing that the application does. So it's worth keeping an eye on this. There are ways you can check for Xposed, because Xposed actually puts a jar file. It injects a jar file into the application. So you can check for that. Check for emulator. I don't remember the last time I put an application in release mode and this application had to run on an emulator. In debug mode, yes. Well, as it turns out, most people who hack applications, they hack it on the emulator because it's much easier. You're on a laptop, you're on a computer. You don't have the small keyboards. You can do whatever you want to do. Checking for emulator can be as easy as this. However, I must point out that there's a bunch of different emulators. There's Genymotion, there's the Android emulator, so there's a bunch of different emulators, so you kind of need to go and check for all of them. Check if the application is debuggable. I usually get the question, well, you're telling me to check if the application is debuggable. Well, obviously, if I publish my application to the Play Store, it's not debuggable, right? It's in release mode. Well, changing an application from release mode to debuggable is as easy as just changing the manifest. So I just said, Android debuggable true. Now this application is debuggable. And if an application is debuggable, as you know, all the traces and everything will be spat out. They will come out. So if you have anything, any kind of logic or anything in your application, well, this is one way. And this is the point where people say, hey, I'm unsure, like, what should I do? I have this application, I haven't done any of these things. Should I go back and tell my boss we need to start again? What do I do? So that's the points I tell people. There are things to look at, so that's the good news. The first one, ProGuards and DEX Cards. I'm sure that if you're using Android Studio, you're probably using ProGuard. Good thing about ProGuards is it's installed by default. It's got name obfuscation, so it changes names of your methods. It's got code optimization as well, and it removes redundant code, so it does some cleanup for you when you compile the application. Now, the counterpart to ProGuards is called DEX Cards, and as you can see, it's just like the logo upside down. It does a few more things. It does class encryption, co-heising, string encryption, certificate check, so it does a bunch of things for you. But you're wondering, so why am I using this when I can use this? That one is free. This one costs money. This one also has a license that is slightly weird because you pay for the number of users you have, and this can vary quite a lot. So you can be paying something this year and maybe a lot more next year if your user base grows. But if you have an application that needs protection and you don't want to go through all the things I told you about, you can just go and use something like DEX Cards. You get things like class encryption. It does certificate checks for you. It checks for debug. It does emulator detection. So it does a bunch of things for you out of the box. You don't need to do anything yourself. Great. Things to look at. Look at the Safety Net API. Who's heard about the Safety Net API here? Okay, so not many people. Safety Net API is an API by Google that checks for things like device compatibility, for example. And the way it does, so what it does is, whenever someone installs your application, it will make a request to Google to say, hey, this is all the information I have about this device. And this information will, well, you get a response back saying, is this device compatible? And when I say compatible, I mean, is it compatible with the Play Store? Is this device rooted? So at this point, you can make a decision. Because the one thing that you may have learned by now is checking if a device is rooted manually works. But hackers are getting more and more smart about hiding the fact that a device is rooted. So this has a much better chance of telling you whether a device is rooted or not. And then at this point, you can make a decision like, should I continue with this? Should I not? Should I tell the user to get out? Network security configuration is another favorite of mine. Okay? So all these things I'm telling you about, Safety Net API, network security configuration, these are all free. Okay? You can make requests to Google and you can get this information from them. Network security configuration works in a slightly different way, but it does some really cool things for you, which I'm going to list now. It does certificate pinning. It does debug override. So if someone changes their application from release to debug, this thing goes and overrides it. The downside is it only works from Android N and above. So this is API 24. Now the good news is someone, a community user, ported this thing to work on API 17, which is 4.2 and above. So if you are building anything from 4.2 and above, you can use network security configuration. It's a ported version, so it's not the official release. So just be careful with that. But if you're building anything from Android N and above, you can use that. And you will do most of the things I told you about out of the box. Like, you don't need to make any effort. You just add this to your application, and off you go. I realize I only have 5 minutes here, so I just kind of want to close with one important message. So if you don't remember anything after this talk, there's one important message which I want to leave you with. Not everything is what it looks like. So I am sure this bus won't take you to Hannah Montana's concert. Okay, so not everything out there is what it looks like. People will try and hack your application. People will try and do things to maybe harm you, or harm your application, or harm your company. And you as a developer, it's your responsibility to make sure that they can't do that. It's your responsibility. It's not anyone else's. It's your responsibility to make sure that the apps you build are protected and are secure, and they're giving the users the security they deserve. Because when it comes to safety, you need to make sure you protect yourself. With that, I have been Marcus Placona. My email address is in there if you want to send me emails, if you want to tweet me or whatever. And I'll be out here if you have any questions. Thank you very much.